Greetings, Skywatchers, and welcome to the sky above us. I'm Lieutenant Commander James Albury, and I'm your tour guide to the night sky. If you're a die-hard Star Trek fan, you'll probably recognize the term stellar cartography. Cartography is defined as the science or practice of drawing maps. In Star Trek, stellar cartography is the division in Starfleet that maps the locations of stars. In the almost 700 hours of Star Trek content that's been produced, the cast of the show visited many exotic planetary destinations. Several of these fictional planets orbit around stars that you can find in the real night sky. So, in this episode, we're going to check out some of the stars of Star Trek. Engage. Okay, first we need to talk about interstellar travel in Star Trek. In the real universe, the distance between the stars is enormous. It's so large, in fact, that we astronomers don't use miles or kilometers when measuring distances in space because the resulting number would be ridiculously big. So, we came up with the light-year unit of measure. Light travels at roughly 186,000 miles per second. In miles per hour, that would be almost 700 million miles per hour. From our terrestrial point of view, the speed of light is really fast. For example, if you traveled at the speed of light within our own solar system, you could get to any destination within just a few hours or less. At conventional space travel speeds, such a trip could take months or years. But in terms of interstellar space travel, the speed of light is painfully slow. In the real universe, the speed limit is the speed of light. As we currently understand it, the physics of our universe does not allow us to travel faster than the speed of light. Oh, you can get as close to the speed of light as you want, and it will take a tremendous amount of energy to do it. 0.99999 times the speed of light is perfectly fine. You just can't get that last little bit to bump the decimal up to 1.0, without totally violating the relativistic equations of spacetime. Therefore, the writers of Star Trek found a way around that with an FTL, or faster-than-light, propulsion system. In Star Trek, it's called warp drive. Simply put, the warp engines, or nacelles, produce a subspace field around the vehicle, distorting spacetime. This distortion, or warp, allows the vehicle to travel hundreds or even thousands of times the speed of light without all the aggravating relativistic effects of length contraction, time dilation, and mass increase. So, instead of taking 4 years to get from Earth to Alpha Centauri, at warp 3, it would take a little over a month. At warp 5, it would take a week, and at warp 9, it would take a day. Our galaxy, though, is insanely big, and even at warp speeds, it takes a lot longer to get to the planetary systems in Star Trek than you think. Let's check out our first system, Mintaka. Mintaka is the westernmost star in Orion's belt. You can find Orion easily just after sunset in the wintertime sky. You can also find Orion in the early morning sky between late August and early November. The name Mintaka is derived from the Arabic word for belt, and this star system is approximately 1,200 light-years away from Earth. In reality, Mintaka is a multiple star system containing over half a dozen stars. In Star Trek, it's home to the Proto-Vulcan civilization living on the third planet in the system. This planet is called Mintaka 3. Just to give you an idea of how far away this system is from us, according to the warp factor scale used in Star Trek The Next Generation, warp 1 is the speed of light. If you were to travel to Mintaka 3 at warp 1, it would take you 1,200 years to get there. At warp 5, you're traveling 215 times the speed of light, so it would take you almost 5.5 years to get there. But even at warp 9, 1,200 light-years is not across the street. Warp 9 is over 1,500 times the speed of light, so it would still take you a little over 9 months to get there. Much longer than your average commercial break. Let's visit a system that's a lot closer. We're all familiar with Mr. Spock's homeworld, Vulcan. In Star Trek, there have been 2 possible real universe locations for this planet. The first candidate is Epsilon Eridani, also known as Rann. It's an orange dwarf star a little over 10 light-years from Earth in the constellation Eridanus the River. Eridanus is a huge constellation just to the southwest of Orion the Hunter. Astronomers have actually found what may be a planetary system, including an asteroid belt surrounding Epsilon Eridani. So far, we have no direct images of planets orbiting Epsilon Eridani, but we're getting closer to having that technology. The other candidate is 40 Eridani, also known as Keed. This system is 17 light-years from the Sun and is a triple star system. Gene Roddenberry confirmed that this star was the one in Star Trek where Vulcan was located, and at warp 7, which is 656 times the speed of light, you could get there in about 9.5 days. Not bad considering. The last place we'll visit is one that was the site of a great space battle between the Federation and the Borg. That's Wolf 359. Yes, this is an actual place. Wolf 359 is a red dwarf star in the constellation Leo the Lion. In the sky, it's very close to the ecliptic and only 7.9 light-years from Earth. This made it a great location for a nearby Borg confrontation. Unfortunately, the star itself is very small and not very bright. Wolf 359's apparent magnitude is only 13.5 and can only be seen with a large telescope. The reason the Federation was panicking about the Borg being at Wolf 359 is that at warp factor 9, the Borg could reach Earth in only 2 days. You can find out more about how the battle turned out in the Next Generation episode, The Best of Both Worlds. Remember, resistance is futile.
Resistance is futile.
All right, my friends, those are just some of the stars of Star Trek. We'll have a sequel to this episode in the coming months, where we'll visit even more star systems, so keep an eye out. Before you go, visit our website, theskyaboveus.org. From there, you can watch previous episodes, listen to the Sky Above Us podcast, purchase the Sky Above Us merchandise, and you can even ask me an astronomical question that I'll answer in a future episode. Plus, if you'd like to support our program, click on the Patreon link in the description, and you could qualify for autographed The Sky Above Us memorabilia, and you could see your name in the credits of our next episode. Star trekking across the galaxy is fun, especially when you remember to keep looking up.